My lab at Material Science and Engineering Department focuses on soft material and nanotechnology. In the next few minutes, you will see our students fabricating materials for new functionality and better performance. We're utilizing bio-derived, biodegradable polymers for creating food packaging, water-resistant coatings, and even helping NASA build additive manufacturing capability in the space station. Recently, a group of undergraduate students launched a new reform program helping Iowa State campus recycle plastics and 3D print them into useful tools and music instruments. I'm very proud of our students utilizing their talent, knowledge, and expertise and helping us build a better and more sustainable future.
My name is Becky and I work in the Material Science Department, but I also collaborate with the Food Science Department for making bio-based packaging. So I have some examples of some samples that I have made. These samples are really special because they are not only bio-based, so no need for petro-based chemicals, but also they are biodegradable, so they will never sit inside of a landfill for an extended period of time.
My name is Emily Olson. I'm a fourth-year doctorate student in the Materials Science and Engineering Department. My project focuses on integrating polymers from nature with nanotechnology to create high-performing coatings with properties such as water repellency and self-cleaning. So I'm going to be adding a small amount of water to each. This is the treated sample. Notice how the water rolls off really well, and it doesn't take that coating with it. Versus the untreated sample, very poor water repellency. You can imagine this may be useful over like the lens of the car camera, or maybe your windows or in your kitchen. You'd never have to clean these windows as the water or stains would just come right off.
Hi, I'm Kyle, and I'm working on a project where we're trying to improve the efficiency of delivering DNA to plant cells. It's trying to take these heavy particles and sticks the DNA to them. The way we tested that it's worked well is we bring them back to our fancy microscope and we scan the whole thing, and if they glow green like this, then that means we've got a successful DNA delivery.
My name is Fei. Our lab is developing nano ink for additive manufacturing. The ultimate goal is to help NASA to build the capability of manufacturing electronics in space station. This is a pattern printed by our nano ink.
Hello everybody, my name is Eamon Carmi and I'm a junior in Material Science and Engineering. I'm also the student president of the Reform program. Now, Reform stands for Recyclables Evolved from Offsourcing Remade into Music. But what does that mean? Well, our program aims to turn plastic waste consumables like this into musical instruments and instrument parts like this. Let me show you how it's done. So, once we get our plastic waste consumables, we want to sort them out. We want to get all the different types of plastics like PLA, PE, PET, all sorted into different categories such that we can grind them down, wash them, and clean them into suitable plastic pellets. These plastic pellets will be fed into this extrusion device. We put the pellets in here, and they become melted down, and they become forced out this end, from which this spooler will collect them and turn them into a roll of filament like so. Now, follow me over here. The printers that I have behind me, these two, they cannot print this filament that we've created. But there are also many possibilities to print different types of resin, such as with our B9 Creator and our Bison 1000 printers. Now, the printers that can print this filament will be our printers like this one, affectionately named Hot Rod Henry, and our Ultimator 2.0. What they'll essentially do is they'll take this filament and therefore the plastic waste components and turn them into something useful and beautiful.
Here we are at the CCL lab of the Architecture Department, where every day students are 3D printing models of their projects. Unfortunately, those projects, like these prints, can't be reused, and the plastic waste is just generated, pounds and pounds of it. So here I am with my colleagues Brett and Abby, and where we have established and are refining a process for recycling these old prints into new 3D printing filament that we can then use to create brand new prints like this without any plastic waste, so we can continue a sustainable future for the CCL lab.
CCL lab
lab where we're doing our process. And so that starts with Alex here putting our ground up filament into what we call an extruder, and that melts those pieces down and spits them out. And we have our fan that cools that filament as it comes out, and it goes through this drive wheel. And over to Brett here, who's spooling it up so that it can then later be 3D printed.